So let's get into this. In the notes that I kind of started in the other um, video, YouTube, whatever, I got through about right here, and then we stopped. So you should have these gray, blackish ones here on the first page, and then the base of that paper is where we're going to put the little squares that have to do with convergent boundary. So on the back of the page that you were taking notes on, we're going to start with this part here. So a divergent boundary, we kind of talked about this when we did the homework page. This is where they dive apart, they pull away from each other. The plates are going to move in opposite directions, and they tend to create a deep valley. The example that we're going to use is the Rift Valley off the coast of Africa. So if you look at the very top right picture, the red line that's on the continent of Africa, there is where the Rift Valley is being created. So Madagascar is that weird kind of teardroppy looking piece off to the side, and at one point that was connected to part of below the Horn of Africa. So the red line, if you're looking at the red line, the gray space to the right is considered the Horn of Africa because it kind of looks like a rhinoceros horn. And then right underneath that is Madagascar. So eventually that red line will be New Ocean, and those gray spots, those gray countries to the left or to the right of that red line will become new continents, new microcontinents. And then the other example is the Midatlantic Ridge or the Mid-Ocean Ridge. So if you look at the picture on the left, the divergent boundary moves apart. As it pulls apart, the magma kind of fills in the space that's there. Then water will accumulate over time, either by rainfall or glacier meltings, or just the flow of ocean waters in. And then over time, you get this rift, or not rift valley, you get this ridge line of mountain lines underneath the water, and eventually they will reach the surface or come up above the surface. So the Mid-Atlantic Ridge is always growing. So if you're writing notes, I would definitely have written down the stuff that's there, and then the white part that's at the bottom. The Atlantic Ocean is always growing. So the Mid-Ocean Ridge is being created every day. And as the two plates, the African plate and the South American plate, are moving apart from each other, so if we think back to Pangea and how they were connected at one point, and now they're moving further apart, we can look at this picture, and this is the red line that's there is the center part of the Mid-Atlantic Ridge or the mountain range. And the further they go towards the continents, the older the rock is. The closer they get to the ridge line, or where the plates are pulling apart, the newer the rock. So when we talk about Iceland, if you are writing notes, please don't write everything down. You're going to write the very top thing and the very bottom thing. So with Iceland in and of itself is a fairly small country. It's a fairly small continent, but it's right on top of these two plates they're pulling apart. So it sits on the Mid-Atlantic Ridge. You could, if you wanted to, go visit and see where the actual crust is pulling apart. You could, if you want to brave the cold, cold waters, and go snorkel, and you can actually go see where the continental divide is happening. So scientists think that it's important to study Iceland specifically because they can see what's happening on the ocean floor, but they can look at it from the surface because they can stand on top of the land and look at it. After the two dots where it says Iceland is splitting along the North American and the Eurasian plate. So North America is moving west and the Eurasian plate is moving east, so they're pulling apart. Iceland has earthquakes and volcanoes almost daily, so they either have some kind of little volcanic sputterings, so the little of the volcanoes, or they have some kind of earthquake that occurs. The picture that's on the bottom is a fault line. The pink line that's there is actually the line of the divide. And if you look, there's a little road there because the road was on the same surface. And the pink line marks where it dropped. So that gray area that's being pointed to by the yellow arrow is an actual like 10-foot drop in the plate boundaries where they've shifted. So then seafloor spreading. If I'm writing notes down, I'm probably going to write the first arrow, the first little star, the second star. That's about it. So seafloor spreading. If you look at the two pictures, the bottom one is the convection currents, and we talked about those at the first video. And then in this one, it's just kind of showing how they're turning, always moving around. In the top picture, the yellow arrow is pointing to the Midatlantic ridge line, so those mountain lines, the mountain range that we can see from space. So like the International Space Station can actually take pictures of it. We can see it from space. It is the longest chain of mountains. It's the longest grouping of mountains. And most of it is underwater, like hundreds of meters underwater. So eventually, in a couple thousand years, this mountain range will come up over the water line and we'll be able to see it. So the mid-ocean ridge, the bottom star, is where molten or melted material rises from the mantle as it's erupting. So seafloor spreading, it's the pulling apart. It's a divergent boundary still. It's the new land that's being made. And then the new material that's being made adds to the ocean floor. So this is how we get our quote-unquote new land. So transform boundary. If I'm writing stuff down, I'm writing the first star, the second star, third star, last star. So transform boundaries are when two plates slide past each other. These plates move in opposite directions. They cause earthquakes and a release of the energy. So it's not actually the movement of the plates, but it's the buildup of the pressure. So if you think about when somebody shakes up a soda and they undo it and it's that release of that carbon dioxide causes the bubbles to come out. So that's kind of what happens here. It's the release of the built up energy. And then our two examples are the San Andreas fault line in California, and that's the picture that's on the left. And then Japan has quite a few fault lines on it, or in it, and that's in the picture that's on the upper right. So with our fault lines, you don't have to write these down. This is just for our background knowledge or internal brain knowings. So there's a normal fault line. It's where one plate drops, right? So it just drops down. And these tend to make tsunamis. There's a strike slip. So that's where they're on the same level, but they move opposite directions. So that would be like the picture that's on the left here. And then these make shallow earthquakes. And then there's another one that's called a reverse strike, and that's where one moves up. So we're just going to look at these two. So we have normal where one drops, strike slip where they kind of scoot past each other. So convergent boundaries, so go get your little cards out. Go get the page that has the 4 squares on it. So convergent boundary, on the back of the one that says types of convergent boundaries, that's where you're going to write the stuff that's right here. So convergent boundaries, to converge, they meet in one place. They collide or crash into each other. And there's 3 types. That's what you're going to write on the first, on the back of the square that says types of convergent boundaries. Then on continent to continent, you're looking down at the blue parts. You're going to write the blue parts that are down there at the very bottom. So continent to continent, please put on there that it's sea to sea, right? Continent to continent. They're the same density, so they push up and make mountains. And then our example is the Himalayan mountains. So same density, push up, make mountains. No, it's Frosty the Snowman was going to play. These create our mountain range. And our 2 that we look at, one really is the one we're going to write about, is the Himalayan mountains. That's the blue, the first word in blue down there at the bottom. These are very, very tall mountains, and they're considered folded mountains because as they push, they kind of like crumple in on themselves. Then if you'll find the one that says ocean to continent, on the back of the square that says ocean to continent, We're going to write the stuff that's up at the top in blue. So ocean to continent, O to sea. On the back of the O to sea, ocean one is more dense, so it's going to sink. Continent, less dense, it's going to push up. Say it again because it's not on the paper. Ocean, more dense, sink. Continental, less dense, pushes up. And then this is going to be the third star down there on in the pink. So it makes ocean trenches and volcanoes. Ocean trenches and volcanoes. On the ocean to ocean one, we're not going to write on the back of it because it's going to become the base. But with ocean to ocean, because they're the same density, they both are going to try to sink under themselves. So the older one, the bigger one, will go down first. And then on these guys, we're just going to kind of talk about them so you know where they're at. If you look at your map that was on that one that we colored, and you find the Nazca plate and the South America plate, you can see where these two plates interact. This is one that they like to ask questions about on tests. So the trench that's off of the Andes Mountains, it is the Peru-Chile Trench. It's also the Chilean mountain range too, because it goes up into Chile. The Nazca plate is pushing underneath the South America plate. So the South America plate gets lifted upwards and creates the Andes Mountains. There's lots of earthquakes that can happen here because of the way that they're being pushed up, and because it's being pushed up so quickly, they can lift really fast and cause really intense earthquakes in this area. So here's our map that we just colored a second ago, or that hopefully you will have colored by now. So you can see the Nazca plate and the South America plate. And then this is the page I was telling you about. So you're going to look at this tectonic movement. It's on the bottom of this page. So on the bottom of this page where it says, what causes tectonic movements? It says draw and label on the front tab, write description underneath. We're not going to do that. You're going to draw what's on the next slide. Just draw what's on the next slide. You don't have to answer any questions. I would pause the video for sure. And you are going to draw this on the next, in that little box that looks like this. I think that's it. Yeah. We'll do the gestures when I come back to class. So you're just going to draw this in. That should be most of what we're doing. That should be all of what you need to do for today. I know it's a lot, and I know that for some of you this is going to be kind of stressful, but you got this. You can finish it. If you need help, please reach out. I'm going to stop.